In this lecture, we're going to cover Big Idea 4, Standard 4, and our topic is overall polarity. So we talked about polarity a little bit back in Standard 2. We did what was called bond polarity. So covalent bonds share electrons. We can have a polar covalent bond or a non-polar covalent bond. Polarity is just the separation of charge due to the unequal sharing of electrons. And when these electrons are shared unequally, it results in a dipole. We're going to form two poles. It's going to result in a partial positive pole and a partial negative pole. It creates what we call a dipole. That prefix di means two, like carbon dioxide, it has two oxygens. Dipole literally just means two poles. So an example of something that is polar would be the bond between hydrogen and chlorine. So they are going to share their electrons. This unpaired electron is going to be shared and it is going to form a single bond. But remember, polarity has to do with our difference in electronegativity. Chlorine is much more electronegative. Electronegativity is the tendency to attract electrons. So chlorine is going to have a greater pull on those shared electrons. So those electrons will not be shared equally. Since chlorine has a greater pull on it, the chlorine side of this molecule is going to have a partial negative. Those electrons get pulled away from hydrogen, so hydrogen gets the partial positive. So this would be a polar bond or a polar molecule. It has two poles. So when we did bond polarity, we would calculate the difference in electronegativity and figure out the bond type based on that difference in electronegativity. Overall polarity is going to be a little bit different. So we're going to talk about predicting overall polarity. And to do this, we are not going to calculate the difference in electronegativity. It is going to depend on the shape or VSEPR geometry. So, two options. Our molecule can be either nonpolar or it could be polar. If it is nonpolar, it is going to be symmetrical. And what we mean by symmetrical is that everything attached to the central atom is the same. So let's look at two examples of a molecule that would be overall nonpolar. Something like methane, CH4. Carbon is the central atom. Everything attached to it is the same. This molecule would be nonpolar. Another example, diatomic chlorine. It is symmetrical. It is the same on both sides. This would be non-polar. Something like carbon dioxide, CO2. So look at the central atom, which is carbon. Is everything attached to it the same? Yes, I have oxygen on one side, oxygen on the other. This is another example of a molecule that is non-polar. So we can have non-polar molecules. We can also have polar molecules. There are two ways that a molecule could be polar. It can be asymmetrical. So what we mean by that is that everything attached to the central atom is not the same. The other way that we can have a polar molecule is if there is a lone pair of electrons on the central atom. That's kind of like your trump card. If there are lone pairs of electrons on that central atom, it is automatically polar. Let's say I had CH3Cl. So I draw my Lewis structure. Look at your central atom. Carbon is in the center. Is everything attached to it the same? Well, no, I have 3 hydrogens and then 1 chlorine. If all 4 of them were hydrogens, it would be nonpolar. But this chlorine attached to carbon makes it polar. So carbon has 1, 2, 3, 4 attachments. They are not all the same. So this would be polar. Another example, HF, hydrogen fluoride. Is it the same on both sides? No. This one is symmetrical. It's the same on both sides, so it's nonpolar. This one is asymmetrical. It's not the same on both sides, so it would be polar. Here's where we have to be careful. Let's say we had ammonia, NH3. So we draw our Lewis structure. And notice that all of the attachments are the same. But this lone pair of electrons makes it polar. If there is a lone pair of electrons on the central atom, it is automatically polar. Think of these electrons like a 4th attachment. Nitrogen has 1, 2, 3, 4 electron regions. 3 of them are occupied by a hydrogen and 1 of them is a lone pair. So since all of those attachments aren't the same, ammonia is going to be polar. So let's do some practice. Draw the Lewis structure. And determine the overall or the molecular polarity. Number 1. Let's do boron trihydride. So if I look up boron on the periodic table, it is in group 3. So it has 3 valence electrons. I'm going to place my 3 hydrogens around it. Unpaired electrons will be shared, and I can form bonds here, here, and here. So take a second and think about this one. Is it polar or is it nonpolar? So we're going to look at the central atom. Everything attached to it is the same. So this molecule would be nonpolar. Number 2. Triphosphorus trifluoride. So step 1, we need to draw the Lewis structure. Phosphorus is in group 5. It gets 5 valence electrons. I could draw my 3 fluorines around it. Fluorine is in group 7, so 7 valence electrons. Remember, we never touch the pairs of electrons, but if we have unpaired electrons, they can be shared and we can form some bonds. All right, is everything attached to phosphorus the same? I have 4 electron regions. Fluorine, 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 lone pairs of electrons. If there are lone pairs of electrons on the central atom, it is automatically polar. Again, 1, 2, 3, 4 electron regions. 4 of them are occupied by fluorine. 1 of them is occupied by that lone pair. That lone pair is going to make it polar. Let's do 2 more. So I have carbon with 2 fluorines attached and 2 bromines attached. Carbon will go in the middle. Carbon has 4 valence electrons. I have 2 fluorines and 2 bromines. Fluorine is in group 7, so 7 valence electrons. Bromine is also in group 7, so 7 valence electrons. Unpaired electrons can be shared, and we can form some bonds. Look at your central atom. Is everything attached to it the same? Well, no. Fluorine and bromine aren't the same atom. We have different attachments, so this would be a polar molecule. Last one. Let's do water, H2O. Oxygen is in group 6. It gets 6 valence electrons. Hydrogen, group 1, 1 valence electron. Unpaired electrons can be shared, and we're going to form single bonds. So remember our VS4 geometry. Water is going to be bent, so I drew it according to its VS4 geometry. Think about this one. Is water going to be polar or nonpolar? Well, look at your central atom. Oxygen has lone pairs of electrons. If there are lone pairs of electrons on the central atom, the molecule will be polar.